Well, hello everyone, and welcome to this Mobile World Live webinar. My name's Tim Green. I'm part of the Mobile World Live team, and I'll be moderating today's session on how MNOs can use real-time event processing to personalize promotions and boost revenue. And today's session is sponsored by Effitel. So before we get started, some quick housekeeping. Today's session will be about 50 minutes long, and we'd like to hear from you. So please ask questions at any time, simply by clicking on the Q&A tab at the bottom of your screen. And we'll keep a record of your questions, and we'll answer as many of them as we can in the Q&A session at the end of the webinar. And also, everyone who registered for today's session will get an email with a link to watch again or to share with colleagues who wanted to view it and couldn't make it. So on to today's topic. Now, it's the goal of all mobile operators to create personalized real-time promotions that they can send to customers. Customized offers always deliver the best results, but this is easier said than done. And the problem is that data is held in different units, in different formats, and even in different locations. So the big challenge is how to aggregate and unify these transaction data records. And the second is to give non-technical staff the ability to set up trigger points and promotional events without support from IT teams. So in today's webinar, we'll look more closely at this problem, and we'll find out how Effitel believe they can solve it with their platform. So to help us to do that, I'm delighted to be joined by two experts, and they are Stefan Banyac, he's the Chief Product Officer of Effitel, and Martin Petkoff, who's the Chief Operations Officer of Effitel. And we're going to start with a presentation from our guest experts, and so I'll hand over to Martin to kick us off, and then we'll have a Q&A after that. Thank you.
Pleasure to be here, and thank you for the opportunity, Tim. Thanks very much for the introduction. So, as I'm sure you're all aware, the telecom industry is undergoing a very rapid transformation. We have global mobile traffic projected to reach about 77 exabytes per month by 2026, and customer expectations are higher than ever. Operators need to move beyond traditional models just to stay competitive and stay above the line. Customers are nowadays expecting instant, personalized experiences. They engage with streaming services, AI-driven recommendations, and digital-first interactions on a day-to-day basis. With these tendencies in mind, telecoms must evolve from just generic offerings to real-time tailored experiences, and just to retain customers and drive loyalty. We know the churn rates in telecoms still remain very high, and they're averaging between 20 or 30% annually. And we all have new market entrants. We have price wars, we have regulation changes, and we also have digital-first MVNOs that operators can't rely on traditional loyalty tactics anymore. That's the bottom line of this conjuncture changes. So the question here is, can we effectively fight this battle? And surprisingly, we hold the key to this question. Telecom data is actually an untapped asset. Operators generate terabytes of valuable information and customer and network data daily, but many of us fail to monetize it effectively. And real-time analytics is what will unlock for us new revenue streams, from dynamic pricing to AI-driven service upsells and predictive network optimizations. The challenges that mobile network operators are facing impact both revenue and customer satisfaction. Legacy systems and offline data processing are in reality creating sensible and sensitive delays and are limiting our ability to take action when needed. These inefficiencies are leading to revenue leakages, ineffective promotions, and underutilized data, all of which hinder our growth and our competitiveness. One major issue in all this is the delay in reacting to critical business events due to simply looking at outdated insights. And when we rely on this paradigm of batch processing, we're actually missing out on opportunities to respond to customer needs instantaneously. And as a result, we, the operators, are losing up to between 10 to 15% of potential revenue due to either inefficient pricing models or simple inability to make real-time data-driven decisions. And monetizing data effectively requires moving beyond the reactive approaches to proactive and real-time insights. To conclude, traditional promotions are often failing because they lack real-time targeting. And many campaigns tend to be generic. They are sent at the wrong time or do not really consider customer behavior in real time as it happens. For example, if you offer a discounted data bundle hours after the customer has already purchased one, is a missed opportunity in itself. Much of the data that the operators are generating on a daily basis remains heavily underutilized, and instead of being leveraged in real time, it's often stored for reporting purposes or post-factum activities. We have studies from various industries that are indicating that operators could increase revenue by up to 15% if they actually leverage on real-time analytics. What is the common factor across all these challenges that I spoke about? Well, it is the delayed decision making, and it's actually very costly. We believe that operators should shift from batch-based insights to real-time intelligence, aiming at what I call ninja-style actions. We can all agree that data is our most valuable asset, right? But for telcos, subscriber data is not just a byproduct of network operations. It's in fact a gold mine of insights that, if and when leveraged correctly, can turn into a massive competitive advantage. Every day, subscribers are generating between 10 and 50 terabytes of data with a tendency of growing. However, just having these details is not good enough. Its value lies in real-time actionability. And our ability to process, analyze, and act on data instantly is what would separate industry leaders from those who might probably fall behind. Leveraging real-time analytics would bring tangible benefits across multiple areas, and just to name a few, hyper-personalized offers based on real-time behavior may increase ARPU. Network congestion and faults can be detected and mitigated before in reality impacting users. Churn risks can be identified a lot earlier, allowing for proactive retention strategies. Activities, for example, like SIM fraud or abnormal call patterns, can be flagged instantly. And the ability to predict customer needs and deliver instant responses will enhance market differentiation. The shift from historical analysis to real-time intelligence, we believe, is no longer optional. It's a necessity. And we have a little joke in our company that says that using reports for analytics instead of real-time data is pretty much like being an archaeologist. So by the time you actually dig up the insights, the subject of your insight digging can only be some fossils somewhere lying around in the databases. Where has our conversation taken us? It's taken us slowly to the point of considering the possibility of leveraging personalized promotions, which, although are considered to some extent a controversial possibility, we strongly believe are in fact a real and low-hanging opportunity for operators, especially in the context of real-time analytics at play. In a world where attention spans last literally seconds nowadays, the difference between customer staying or leaving isn't just the discount on the products that we offer. It's whether we offer it at the right moment and at the right time. In fact, there was a study done by Microsoft in 2015, the purpose of which was to determine what is the average amount of the attention span of an average person. And it turned out that nowadays it's actually 8 seconds on average, which is a drop down from 12 seconds back in 2000. And that is 8 seconds of average attention time span per person. Just to make a brief comparison, the attention of a goldfish is 9 seconds. So I'm not saying that we lost it to goldfish, but the fact of the matter is that you really need to act at the moment things are happening in order to draw the attention of the end user and to actually monetize and or prevent certain things from occurring. So let's have a look at the following use case that we have offered here. That a customer can be using most of his free data on social networks. And what we can do when we leverage real-time data analysis is to basically in real time determine out of the entire flow of data if the customer is having a variation in their usage pattern for data. For instance, we can relate the current data usage to the previous dates of data usage, and we can see a spike or a peak in a particular social network that is interesting to the customer at this point of time and is actually consuming its vast amount of its available data allowance. So what we can do at this particular moment is to push a personalized promotion that would allow a customer to probably purchase a data bundle that is targeted to this particular social network and answer to this demand in real time. And the implication of such approach is that we have an increased engagement, first of all. We definitely have an increased customer loyalty and an incentivized user behavior. Key KPIs. Real-time analytics fit well not only with individual markers like the ones we spoke about, but also global KPIs that are relevant to the overall customer base, such as, for instance, the RPU that we are all aware of and that we track very often and very frequently, and also the customer lifetime value. In fact, waiting for mission-critical reports is nearly like checking yesterday's weather to decide what to wear today. Real-time insights can actually help us act before our revenue sleeps away. Real-time RPU and customer lifetime value reports and monitoring, for instance, can be used to perform dynamic market segmentations, which can be leveraged to treat high-value customers more adequately whenever needed. Identifying and segregating market segments can be effectively outsourced to an algorithm that we also apply in our practice, and we see it delivering quite interesting results. Imagine the situation in which you could track the RPU, but not for your entire customer base, but for each and every subscriber that you have on your platform. We can do that with the help of the technology that we'll discuss in a bit. And whenever you can tap into the data of how valuable is your each and every customer, you can perform a lot more sophisticated segregations that can be very useful to targeted campaigns. Next to this, we could track in real time our port outs versus port ins, which we call porting surplus, and correlate some deviations in both directions that are based on changes that happen in our or our competitors' conjuncture. For instance, such deviations can trigger us to either boost further a campaign that we have started and has resulted in very positive migration to our network, or counterattack a competitor's offering that is resulting in us leaking customer base. And again, we can do all that in real time when we have real-time analytics. Before we move into technicalities, I just want to establish what is real-time event processing to ease out the rest of the conversation. To give a definition to real-time event processing, it's a type of data handling that encompasses, in our opinion, three distinct and interdependent activities. Capturing of data on one hand, which needs to happen as funneling of data through an interactive funnel, able to analyze it, make sense of it, aggregate it, and based on some patternized or trended analytics, and finally act upon it, which is the ultimate goal of real-time analytics. To conclude, again, it's capturing, analyzing, and acting. This is what real-time promotions are heavily relying upon. The acting part is where the beauty lies in. We can take immediate actions based on certain triggers, conditions, patterns, or things that we see and believe are requiring us to make a move. The totality of triggering and compelling events for us to make a move are limitless, and we can create all those on the fly. When making a move, however, we have to, again, remember that we aim to deliver meaningful customer interactions that make sense individually to the clients. Switching to technologies, let's talk a little bit about Apache Kafka, which is the culprit of the discussion today. Kafka is, you can call it, many call it a distributed event streaming platform that is specifically designed for very high throughput. It facilitates event-driven communication. It allows producers to broadcast messages to the Kafka messaging bus and consumers to consume those messages. When we put in the picture a technology like KSQL, things become very different because the exchange of messages turns into a highway that can be used for conducting real-time analytics and conducting real-time operations based on our findings from this analytics. Kafka acts as a message broker, and it enables seamless telecom data flow. And I will explain the differences from the standard telecom backbone. And its key features are ultimately fault tolerance, real-time data streaming, and an incredible scalability that many companies are putting into practice. Are there any large users of Kafka implementations? There definitely are. I've named a few here, but Kafka is nowadays used in many companies out there. And it has a fantastic roadmap. It has great supportability, and it has turned into an extremely reliable framework on which can definitely respond to the needs of the telecom industry. We all know that the telecom industry has its expectations, and those expectations are very high. They're setting the trends in many cases. But given the fact that companies like LinkedIn, for example, Netflix or Uber have chosen Kafka as a framework to support real-time analytics, simply um, substantiates the fact that it is the right platform to be used for such purposes. To briefly touch based upon these companies and their choices, in LinkedIn, Kafka is processing approximately 7 trillion messages daily, and they have over 100 Kafka clusters, and that is a tremendously complex deployment. However, it seamlessly works in a highly available environment, and it supports all the capabilities that we know and we consume on a daily basis from LinkedIn as a platform. Netflix, on the other hand, which we are all very well aware of, tracks the activity of over 230 million subscribers using Kafka, and it uses it as a data store, storing details of, for example, usage and watch history, customer preferences, and so on. So it pushes targeted proposals to the customer base of Netflix of what to watch next, for example, or so on, based on certain criteria. Uber also utilizes and has one of the largest Kafka deployments globally. And it is used to facilitate data interexchange between drivers and passengers in real time. KSQL, on the other hand, is a very interesting concept. When I first saw it, I was absolutely wowed by it because it was like the wet dream of anyone who ever thought about real-time analytics. For the ones of you who are aware of the SQL as simply a language which is used to query static data in databases, it is SQL on steroids. It gives you pretty much the ability to query in real time the data streams that are going through your Kafka cluster and the various Kafka topics that are published there, and dynamically update the results of the query as data passes through those streams. So in reality, it is a real-time query language that continuously updates the results and gives you the possibility to make use of the data in real time. It also super simplifies data analysis because it removes from the equation the need to develop code in order to tap into that data. It provides an interface which is SQL-like, but moreover, it can be easily combined with natural language processing algorithms that make it absolutely possible and simple for the end users to use human language and describe the query that they want to create, and then translate it into KSQL query that starts returning those results in real time to the user. And later on, Stefan will show you a couple of examples how we have implemented in our platform. You can apply so many different real-time monitors that imagination is the only limit to what can be put in practice with KSQL in conjunction with Kafka. So the benefits of Kafka and KSQL in the telecom are numerous when they're properly put into practice. First of all, Kafka can be the answer to having your data available to you in real time. It answers the question of scalability, and it provides you, in conjunction with KSQL, what I call low latency insights, which superpowers your on-the-spot decision making. And it also gives you the possibility to seamlessly integrate with your existing BSS and OSS components, which we'll also touch base upon a little bit later, that can help you automate your decision making in literally any environment, irrespectively of the BSS and OSS platforms that you are employing. So how Kafka transforms the telecom data streams. In the typical setup, you have what I call the hopped approach. You have one platform producing data, delivering it to the next platform taking it, processing it, delivering it to the next hop, and the next hop, and the next hop, and so on. And each and every of those hops introduces its latency, first of all. It introduces its duplication of data that we know leads to certain types of problems. And essentially, you need to run coding on each and every of those nodes to make use of that data, and you don't necessarily have it in a correlated way. What Kafka creates and what Kafka is it can become the real-time nervous system of your business, and it can turn the raw, dull, and endless and currently unused, I would say, events into instant and actionable intelligence. It can be, again, the highway on which you make data available before it's needed even by downstream systems. It simply runs through the neural system, as I call it, and it can be used by certain consumers whenever such need arises. Stefan, I will hand over to you now.
Thanks, Martin. Well, as Martin indicated, I'll try to help you look at a few real-world telco examples of Kafka in action. Actually, the first one he already mentioned. If you imagine a customer who reaches 90% of their data limit, without real-time processing, they might only find out when their data is cut off. In this use case, we obviously also rely on the real-time rating of the data, which we achieve using our OCS. That, by the way, produces data records during the session, not only at the end of it. Later, with the help of Kafka and KSQL, we can detect this event immediately and trigger a targeted notification offering, let's say, a top-up plan. This not only enhances the customer experience, but also boosts revenue through additional purchases. This is a prime example, I would say, of real-time event processing, creating a win-win for both telecom operators and their subscribers. What else we got? As mentioned by Martin before, churn is a massive challenge in telecom, and we are often asked to help reduce it. Our experience shows that two pivotal things to diminish churn are identifying behavioral patterns and acting promptly. Some of the common patterns are declining usage, late payments, fewer interactions with self-care, sudden switch to low-cost plans, increased complaints to customer care, etc. As you can imagine, with real-time event processing, we can monitor those more efficiently. So Kafka processes these patterns, and KSQL triggers retention strategies such as offering discounts, loyalty perks, or personalized engagement. To conclude, By acting on churn indicators instantly, telecom operators can make a significant impact in preventing customer loss and improve long-term retention. Let's go through one more. I think we would all agree that ensuring high-quality service is critical for customer satisfaction. Kafka enables us to monitor networks in real time, including detecting congestion and checking on latency and jitter before they impact user experience. For an example, if a cell site exceeds 500 users and throughput drops below 5 megabits per second, Kafka can alert and trigger automated network optimizations. This means fewer dropped calls, better video streaming, and a seamless user experience. So, by proactively managing network performance, telecom operators can reduce complaints and improve overall service quality, which also impacts the previously mentioned churn rates. Allow me to use a few minutes to showcase to you just a bit of how we leveraged on Kafka in the micro BI module of our BSS platform. Basically, users are presented with a telecom analytics dashboard that monitors key business KPIs. As you can imagine, you can configure an unlimited number of them and decide on the look of your dashboard. As visible here, you're able to observe the data in different time windows. These insights are critical for decision making, and Kafka enables this by acting as a backbone for streaming data. And the choice is yours, whether you will react to it upon looking at it, or you will configure automations to do the trick. What is important to mention is that flexibility we have with KSQL and the scalability of Kafka as a whole allows us to observe data from various angles without fear of making mistakes and causing performance issues. So not only do we use this setup to observe global indicators and check the total number of calls, messages, or volume of data for whole subscriber base, but we can also make a setup where this is tracked per subscription. Thus, we set up an individual KPIs. We can support use cases as the one I previously talked about, where we would instantly react to data limit being breached, inform the customer, and offer a promo. Given we have a limited time today, let me finish with insights from our platform with an example of a use case for event-driven automation in telecom, where the promotional campaign is being configured based on the real-time spending patterns. Just in a couple of minutes, using intuitive UI, you can configure a campaign that will, in this example, benefit the community of prepaid students if they end up spending more than 10K euros in total in a period until end of the year for the purchase of particular product you would like to promote. Without Kafka, such workflows would rely on batch processing, leading not only to delay and missed opportunities for customer engagement, but in our experience with legacy platforms, it might even lead to errors, given that inputs have changed in the meantime. Kafka real-time capabilities allow any provider to react dynamically, which is one of the main drivers of revenue growth. Coming back to the challenges, what our experience tells us is that MNOs are usually concerned with the integration aspect. So the question is, how does Kafka fit into telecom legacy systems, allowing the introduction of real-time event processing and transformation of batch-based operations? Well, network elements, including OCS and mediation, are the ones to generate big amounts of customer-related events, and we observe them as producers in the Kafka paradigm. These events are published to relevant Kafka topics that we categorize based on event type or whatever criteria we come up with. Finally, KSQL queries process this data in real time, producing actionable insights that can be consumed by anyone subscribes to Kafka, including legacy platforms. And we can connect Kafka with legacy BSS OSS using store procedures, APIs, customized adapters, or anything that can make the certain operations of the system available. Moreover, to make it bidirectional, traditional BSS OSS can consume Kafka events in multiple ways. Using Kafka Connect, JDBC, or HTTP Sync, We can push real-time data into relational databases. API triggers or file-based integrations are options as well. Last but not least, Kafka can generate real-time files for batch-based systems, or we can use custom adapters that can be written by developers in any programming language. One of the beauties of this entire paradigm is that Kafka enables hierarchical processing where one KSQL query can feed into another. Think of it little like a waterfall, where the first level queries can, let's say, detect unusual spikes in data consumption. The second one would identify high-value customers that are affected, and the final query can trigger an instant offer to optimize experience and positively impact revenue. As a final takeaway, the true power of using it is unmatched flexibility. With Kafka, telecom companies can modernize legacy systems with real-time capabilities without expensive rip and replace projects. It's the bridge to the future, enabling seamless event-driven telecom operations. If we discuss how telecom operators can implement Kafka step by step, in short, it looks something like this. The step one is connected to data. It is important to identify key data sources such as customer interactions, network performance, transaction logs, etc. Once that is done, deployment kicks in, where a scalable Kafka infrastructure to handle data ingestion and streaming should be set up, making sure Kafka is connected with existing telecom systems. Only after that can the implementation of KSQL queries to extract insights and trigger actions be done to ensure real-time processing. Later on, practice just makes it perfect, I would say. The more tests, iterations, and data, the merrier. To wrap up, allow me to highlight the key takeaways from today's session. Real-time event processing creates new revenue streams by enabling personalized promotions. It enhances operational efficiency by automating decision-making and network optimizations. It strengthens fraud prevention by detecting anomalies instantly. It provides a competitive edge by ensuring operators can react in real time. And finally, it drives stronger customer retention by proactively addressing churn and engagement. Thus, it's all about embracing real-time analytics. With it, you can future-proof your business and stay ahead of competition. And that's basically the end of our presentation today. So we are more than happy to answer any of the questions.
Well, thank you, both of you. That's really interesting stuff. We've got about 10 minutes for a few questions from me and then 10 minutes for some questions from the audience. So, Martin, I'll come back to you first. You talked, both of you talked a lot about the ability of non-technical staff to use these solutions with no coding and the addition of natural language processing and so on. Can you, Martin, can you start by sort of giving us a vision of how this looks for these staff inside a telecom operator on a day-to-day basis, and what kind of use cases and how the solution actually appears to them?
Sure. Well, as we said already, the number of use cases are virtually limitless. But the ones that are, I would say, the basics that we need to start with are the evaluation of what's actually happening with our customer base. The bread and butter of making real-time personalized promotions is proper segmentation of the customer base. So we need to, first of all, understand what are those segments and then approach them in an individual way. What we usually start with is by connecting the data streams that are basic and fundamental to any operation. And that is customer call data records. Those are transaction data records that encompass payments and product purchases. And we correlate those with the customer information. You can actually, using KSQL, correlate details from databases as well. What we start building is individual and group counters that are, first of all, reflecting on the global KPIs, as we call them. And those KPIs deal with, as we spoke before, average revenue per user, customer lifetime value, but also individual counters that are more relevant to the individual consumption patterns, the types of services that the customers are using, various aggregators that deal with daily usage, weekly usage, monthly usage, and so on. And then when we run the data through those streams and we start accumulating it, we are then starting to see a very interesting picture in our customers' operations that are suggesting that they have, always suggesting that they have different market segments that they haven't been addressing so far. And then it's just a decision making of what to do, what kinds of actions to perform upon these findings. To give you an example, if you observe the usage patterns of your customers and you see that on the weekends they're actually using less of certain services, you can push for them weekend promotions that would encourage them to use those services during the weekend. And it's all about making sense of the data, but once you have it in front of your eyes, from that moment on, you can start putting into action. Bottom line, what you need is to begin with is to create your Kafka infrastructure to connect the most relevant data sources, and then to create the basic stream processors and aggregators in order to gain first insights of what's happening real time in your customer base.
So you talked about connecting data sources there. Maybe, Stefan, I'll ask you this question. I know in some of FTL's promotional material, you've talked about use cases such as linking a bank. Maybe a bank is working with a telecom operator, and a customer is going to get a certain number of some data if they make a certain amount of transactions per month. So in that case, you're linking the bank data as well as the telecom data. Can you talk, Stefan, about some of the challenges of linking third-party companies to these systems?
Well, the challenges are there, like we experience them in, I would say in telco projects, even before we started working with Kafka, the challenge is there where you need to integrate with the legacy system. I would say the analytics part takes the most of the effort. I would say the problem usually relies in the fact that the legacy systems are used to work with the batch-based processing of the data, right? So as I explained earlier, we have some ways to handle that. Kafka can adapt to it. And basically, the lessons we learned around it is that we can, how to say, we can tackle it by developing some custom adapters if necessary. But also there are some Kafka plugins, I would call them, that can help into integrating more easily. Some things that would, for an example, in case of the batch processing, we make sure to carefully decide on the optimal batch size to reduce input-output overhead, to make sure that this integration is optimal. So it's all about careful integration and deployment strategy, I would say, to make sure this works, because telecom heavily relies on the low latency, and we need to make sure that we are, while processing all of this, we ensure the low latency, and we ensure the reliability of the whole setup.
Okay, thank you. Martin, you talked, both of you in the presentation talked about some of the customer stories and use cases. Can you expand on that a little bit? Can you talk about any more real customer stories and the benefits that your customers have discovered from using this system?
Sure. I can refer to a client, for example, that has a client is in Italy. They are a prepaid customer. And they have prepaid customer base, and they have about 1.2 million active subscribers in their operations. What they had before we implemented the platform for them was a churn rate that was about between 6 and 7% per month. And on a yearly basis, obviously, it was quite substantial. So the difficulty that they had was to identify in the case of mobile number portability when their customers are porting out, basically identify beforehand certain behavioral patterns that are typical in the essence of customers planning to do the move to another operator. And this case is extremely complicated if you think about it, because typically the customers would not change their behavioral patterns if they're planning to move to a different operator. However, what could be, for instance, evaluated beforehand is if they're having quite some interactions with some off-net numbers or off-net SMSs, for instance, or things like that. And when we implemented the real-time analytics for them, slowly but surely, they started being able to segregate better a particular usage pattern or set of patterns for a market segment that month over month, when we learned what are the typical patterns of behavior just before losing a customer to an MNP out promotion, we could put them into a more meaningful algorithm of identifying that pattern. And after a period of about 10 months, we were able, on the basis of pushing real-time promotions to customers that entered this particular market segment in real time, pushing them certain promotions, to narrow down the churn to 2.few%, which was a substantial achievement, considering we started from between 5 and 6% on a monthly basis. So that's just one example of how this can be put into practice.
Excellent. And Stefan, back to you. So in the case of an example like this Italian operator, what kind of timescales are involved in onboarding a solution such as yours in order to, gain these benefits?
I'm not, maybe Martin will be better to say on the exact time scale, but the analytics part took like, analytics including the strategy for deployment, because when we are deploying, we need to face some, we are inevitably facing some challenges, and we need to keep on with some recommendations coming from community, and that takes at least a month, I would say, analysis of how we would make the setup to work the very best. As I said earlier in the presentation, it's about understanding the data, understanding in this particular case of churn, understanding how we can recognize and what are the patterns. So from where to dig out that, etc., and how to make the whole setup work with a low latency. That means that even though Kafka scales with the number of partitions, having too many small partitions create overhead. So we need to have an even load distribution. We need to have to balance partition size to avoid broker memory issues, etc. So all of this is part of the process. But I don't know, Martin can correct me if I'm wrong. I think that the whole project setting up took like 2, maybe 3 months. I don't know, Martin, you tell me.
The actual setup took between 2 and 3 months. You're right. The thing that took most of the time is to make sense of the results that were coming out from the real-time aggregations, and then trial and error of how to approach those market segments. So you would run a campaign, you would get some results of it. Some of those campaign cycles would not be entirely successful. Some of them would be not successful at all. There would be no responses. But when the right model of predicting which types of behavioral patterns are most likely to suggest the customer aiming to churn away to an MNP out promotion, then things started getting better and better. And it took us about a good 10 months to fine tune the action taking out from the data that was created from the aggregation algorithms. The actual setup is not such a difficult thing. From the moment you deploy the infrastructure, from the moment you connect all the data sources to the Kafka highway, it can be between 1 and 3 months. And the difficulty, as Stefan said, is when you size the exact, let's say, infrastructure and the resources that you need to utilize, it pretty much depends on the types of aggregations that you're planning to make. The employment of aggregations and nested aggregations, like we call them, the pyramid approach, is what requires persistence of data, and it's heavy on resources. If you're just running transient queries without aggregations, then it's a different story. So the initial sizing and initial hardware provisioning can be very fast. Deployment of Kafka is also very fast. Using Kafka Connect, you can tap into different sources. And I would say that with good level of competence on Kafka itself and KSQL, you wouldn't need more than 2 months to set the whole thing up. If no competence is available, certainly there is a learning curve, and that learning curve to be up to 3 or 4 months for good level engineers. But it's not rocket science whatsoever, and it's freely available out there for anyone to use. And the community is amazingly active, so you can get pretty good insights from it when necessary.
Okay, well, it's pretty quick to get some good results, so that's encouraging to
Absolutely.
know. So we've got about 10 minutes left, so I'm going to move to some audience questions now. Stefan, this one's for you. So this is about legacy systems. Many telecom operators still rely on legacy BSS and OSS that was not built for real-time streaming. So what are the best practices for integrating Kafka and KSQL with traditional batch-orientated systems? And how can event-driven architectures coexist with these legacy billing and CRM platforms?
Well,
Can I actually take this one? I'm sorry, Stefan, but this one is my favorite.
Okay.
Would that be okay?
Yeah, of course.
All right. So again, the legacy systems are not bad systems at all. Many of them are doing a very good job. Many of them are doing exactly what they have to. But the problem is that, as we said in the beginning, they're built for batch processing. And if you want to have metamorphosis from the batch processing to actually doing real-time actions based on the data insights that Kafka can give you, then you need to have some sort of a transition plan from moving from batch processing to the real-time stuff. And well, the good thing about Kafka is that it has this extension called Kafka Connect that enables the connection to legacy databases. So you can use an approach that is called capture data as it changes, identify the exact data from the legacy databases that you need to observe, and then as soon as changes occur in that data, transpose them to your Kafka topics and Kafka streams that you need to evaluate. Now, the other usual approach that the legacy systems have for, let's say, acting upon certain conditions that are met when you do batch operations is either stored procedures or some legacy APIs, like we know some legacy, not legacy, but some pretty solid billing vendors out there are using Corba interfaces. You can leverage on the existing Corba interfaces, integrate them with the relevant Kafka connectors, and ingest actions that are from the legacy domain. You can use operations and APIs that are available in those systems and integrate them quite well into Kafka. And well, step by step, you can move from the batch processing to real-time event operations. And I'm not saying that you can phase out the entire legacy billing system or solution, but certain parts of it you can definitely outsource to Kafka gradually, and you can integrate Kafka quite well into your legacy environments by things like Kafka Connect, for example.
Okay, thank you. Next question's on scaling. So this is many operators still rely on legacy systems that were not built for real-time streaming. So what are the best practices for integrating Kafka with, oh, wait a minute, no, we've done that one, haven't we? Yeah, sorry, we've done that one. So what are the most common pitfalls operators face when implementing Kafka and KSQL? Are there specific lessons to be learned around schema evolution, stateful processing, or operational complexity?
Martin,
Yeah.
you want to answer that one? Or?
Sure, that would be my pleasure. Aggregations, as I said already earlier, are the heavy part. They do require some processing power because they need to store data. They need to persist the state of the aggregation. But Kafka comes with very handy tools for handling such persistences. You can optimize your, it's called RockDB. You can optimize the RockDB settings. You can leverage on windowing techniques, scale state stores across multiple nodes, and ultimately slice and dice and size your Kafka cluster in a way that it would correspond to your data flows and to your data aggregation targets. This requires, of course, some pretty good understanding of the underlying technology and how it can be configured, how it can be optimized for certain types of operations. But as I said, it's not rocket science, and it doesn't take long to actually get a hold of it and understand what are the best practices in configuring it for certain types of operations. Yes, Kafka requires tuning and monitoring. Poor configurations of Kafka can lead to latency spikes and bottlenecks in the overall event processing. However, if you use what they call partitioning strategies, if you, Confluent, for example, has a very good control center solution. Prometheus has very good real-time health monitoring. You can use a lot of the tooling that is available around Kafka to properly apply operational governance around it and make sure that it doesn't introduce any latencies. As I said earlier, the batch-based APIs are making it sometimes hard to consume real-time streams, but Kafka Connect with change data capture, for example, helps to sync real-time insights into batch-based systems. So Kafka and KSQL bottom line are powerful, but they require the right architecture, the right governance, and operational best practices to scale effectively in the telecom environment. And that comes with experience, that comes with actually implementing it and getting your hands dirty with it and understanding how it works.
Okay, well, I thought we had a scaling question, and we have. So it's what are the key considerations when handling high throughput workloads in Kafka, such as processing millions of telecom events per second? Can you recommend architectural patterns to ensure low latency and fault tolerance?
Okay, let me
go ahead.
Okay, let me do one. Well, I'm sure our CTO would be delighted to talk about it. But yeah, there are some recommendations coming from the community outside of telco using Kafka since years. And those, to be honest, prove to work pretty well in the telco setup as well. We mentioned a few of the things. I will repeat some of them and add something on top of it. So basically, Kafka throughput scales with the number of partitions, but too many small partitions create overhead. I think I said that before. And improper partitioning can lead to uneven load distribution and consumer lag. And having said this, what we do is we use key-based partitioning to ensure session thickness, let's say. For an example, key being a customer ID or the network session ID. We balance partition size to avoid broker memory issues, and we enable replication at least 3 times to prevent data loss and ensure high availability. What else we do is that we are optimizing log and storage settings, where basically we are not keeping logs on Kafka itself for more than, I think in our setup is mostly 7 days. Also, if we are integrating with those batch-based system, we make sure that we decide on the optimal batch size to reduce this input-output overhead. What else? As you know, telecom events often arrive out of order due to network delays. And if those are improperly handled, it can lead to incorrect analytics, e.g. misattributed billing. So to address that, we are using an event time processing with watermarks to handle late arriving data. And we tune out of order window grace periods to ensure accurate aggregations. In terms of low latency expectations, what we are doing, we are avoiding stateful processing, and we write those KSQL queries with time-based joins instead of unbounded joins. And in terms of respecting the standards of geo-redundancy setup, it is important to mention Kafka actually can be deployed in the multi-region clusters with geo-redundant brokers to ensure failover resilience. Bottom line is that by optimizing the partitioning, the memory, stateful processing, we are able to achieve a millisecond level latency while processing a very large number of events. Like it's like a million of the rows per second.
Okay, excellent. Well,
I will say start with a cluster of 5 nodes
Right.
as a minimum, and then scale it as you need.
Okay, well, I think we've got like 3 minutes left. So there was another question, but I think we'll have to handle that offline. So, well, amazing. Thank you so much for your time today, everybody, for watching, and also FTL for sponsoring the session. And thanks to Martin and Stefan for all of their insights and knowledge. Just want to remind you that once again, you can watch again when you receive an email with a link in it, and you can share that link with your colleagues. Also, Mobile World Live recently wrote a white paper in association with FTL on this topic, and you can download that from the FTL website, and you can also download today's slides if you visit the website at ftl.com. So with that, I'm going to say thank you once again to Martin and Stefan. Thank you all for watching, and we'll see you all next time. Cheers. Bye-bye.
Absolute pleasure. Thank you. Bye.
Thank you.